A cubic polynomial has the form ax cubed plus bx squared plus cx plus d, where a is not equal to 0. First of all, what is a nomial? Well, a nomial is just another word for an algebraic term. An algebraic term might be something like 2x cubed. This particular term would be a cubic term. Or it could be a quadratic term, something like minus 3x squared. It could be a linear term, something like, say, 5x. Linear means we just have x to the power of 1. If we were to graph this, draw the graph of y equals 5x, we'd have a straight line. We could have a constant term, which is just a number, like say minus 5 plus a half. So these are nomials or terms. By the way, they don't necessarily have to involve whole numbers. A nomial might look like, say, 3x to the power of a half. That's an example of a nomial. But normally our powers will be whole numbers or integers. But the coefficient doesn't have to be a whole number. The coefficient could be any real number. We could have a coefficient of a half here. In our situation, we'll normally be dealing with nomials or terms where the coefficients are integers. So you won't see something like this. And if you do, you can always multiply everything by 2 to get rid of this 2 here. The prefix poly in polynomial means many. So we have many nomials or many terms. For a cubic polynomial, we actually have 4 terms. We also have the condition that a cannot equal 0. So the coefficient of x cubed has to be non-zero, because if it was 0, then we won't have any cubic term. We need a cubic term in order to have a cubic polynomial. Now the letters A, B, C and D usually stand for given values. We normally have those values. The letters from the start of the alphabet normally denote given values. Whereas X is an unknown, or it can vary. So letters from the end of the alphabet like X, Y or Z are used to denote unknowns. We're using the letter X here. A cubic equation has the form ax cubed plus bx squared plus cx plus d equals 0. So we just put our cubic expression equal to 0 and we have a cubic equation. So the standard form is to have 0 on the right hand side when we're talking about cubic equations. Now we're going to be interested in solutions of cubic equations. We're going to be interested in finding the number x which satisfies it. We will find that there are at most 3 roots or solutions of a cubic equation. Actually, the highest power of the equation tells us that there are at most that many roots. So the highest power is 3, so it means that there are at most 3 roots or solutions of a cubic equation. The simplest cubic equation is just x cubed equals 0. We don't have to have an x squared term or an x term or a constant. Another example of a cubic equation might be something like minus 5x cubed plus 3x plus 4 equals 0. In this cubic equation there is no x squared term, but we must have an x cubed term. A very important theorem which relates to solving cubic equations is the factor theorem. It applies to any cubic or any polynomial equation. So we're going to apply it just to cubic equations. The factor theorem says that if k is a root of the equation f of x equals 0, where f of x is a cubic polynomial, then x minus k is a factor of that cubic polynomial. For example, 1 is a root of the cubic equation x cubed plus 6x squared plus 5x minus 12 equals 0. By the way, another word for a root is a solution. Now what does that mean again? It means that if we call this expression f of x, then we have the equation f of x equals 0. If we put 1 in for x, we get f of 1 equals 0. So that's what it means for 1 to be a root of this equation. F of 1 should equal 0. Let's just check that. Let's get f of 1. So we just plug 1 into this. So we'll have 1 cubed plus 6 times 1 squared plus 5 times 1 minus 12. So this gives 1 cubed is 1. We get 6 here, we get 5 here. So this gives us 12 minus 12, which is 0. So 1 is indeed a root of this equation. So the factor theorem tells us that x minus 1 is a factor of f of x. So we just put x minus the root to get a factor of f of x. That means if we divide x minus 1 into f of x, we'll end up getting a remainder of 0. So we will do this by process of long division. We will divide x minus 1 into this, and we'll write our answer up here, which will be the other factor. It'll be a quadratic factor of our cubic equation. And this number here we'll get at the end will be the remainder. Now let's take an example involving numbers, just to explain about long division. If we want to divide 13 into 2613, the first step is to divide 13 into 26. It goes in 2 times. The next step is to multiply. We multiply 2 by 13 to get 26. The next step is to subtract. When we subtract here, well, we actually get 0. Then we take down the next term, which is 1. 13 into 1 won't go. Then we take down the next term, which is 3. 13, actually we have to put a 0 here. Forgot about that 0. We just bring down the 1 actually, so we get 0, 1, or just 1. Then we divide 13 into 1, it goes 0 times with a remainder of 1. Then we multiply 0 by 13 to get 0. Then we subtract. 1 minus 0 is 1. The next step is to bring down. We bring down the 3, write that here. And then we go back to dividing again. We divide 13 into 13, which goes once. After dividing, we multiply. We multiply 1 by 13 to get 13. The next step is to subtract. Subtracting gives us 0. And this is our remainder. In other words, if we multiply 13 by 201 and add on the remainder 0, we get 2613. So we'll be following the same steps when we're doing long division in algebra. So what we're trying to do is get the other factor of this cubic equation. Getting the other factor will enable us to get the other roots. We only have one root, this root, x equals 1. There are at most 2 other roots. Okay, the first step is to divide. We divide x into x cubed to get x squared. The next step is to multiply. We multiply x squared by x to give x cubed. So we get this back. We multiply x squared by minus 1 to get minus 1x squared. Step 3 is to subtract. X cubed minus x cubed gives 0. 6x squared minus minus x squared, that's the same as 6x squared plus x squared, is 7x squared. Step 4 is to bring down the next term. So we take this term here and write it after 7x squared. After bringing down that term, we go back to step 1, which is the division step. This time we divide x into 7x squared. 7 into 7x squared goes 7 times, 7x times. The next step is to multiply. We multiply 7x by x to get back this 7x squared. Then we multiply 7x by minus 1 to get minus 7x. Step 3 is to subtract. 7x squared minus 7x squared, that gives us 0. Plus 5x minus minus 7x, that's the same as plus 5x plus 7x, which is plus 12x. After subtracting, we go to step 4, which is to bring down the next term. Next term is minus 12, so we write that after plus 12x. And we go back to the division step. So we divide x into 12x to get plus 12. We multiply plus 12 by x to get back 12x. Plus 12 by minus 1 gives us minus 12. The next step is to subtract. We get 0 here, and we get minus 12 minus minus 12, or minus 12 plus 12 is 0. So this is our remainder. Now we expected to get a remainder of 0 by the factor theorem. If 1 is a root, then x minus 1 is a factor. A factor means the remainder has to be 0. So in other words, if we multiply x minus 1 by x squared plus 7x plus 12 and add on 0, which won't do anything, we'll get this cubic. Now we can get on to getting the other roots of our equation, f of x equals 0. So here's f of x equals 0. Underneath it, I've written down its factors. We could add on the remainder, but of course, that's just 0. That doesn't do anything. So from the factors, we can get the roots. We have a product of two expressions giving 0. The only way that can happen is if either this is 0 or the other factor is 0. If x minus 1 is 0, that leads us to x equals 1. But we already know that x equals 1 is a solution. To get the other solutions or roots, we put the other factor equal to 0. So if this is 0, then we'll have x minus 1 times 0 will give us 0. So that's what you always do. If you have 0 on the right hand side, if you have a product of things, factors, numbers, whatever, giving 0, then either of them can be 0. Now, let's solve this here. What is this? Well, this is just a quadratic equation. So we've already covered those. How do you solve them? Well, you can use a formula or you can try and factorize them. I'm going to factorize this one. Factors of plus 12 are plus 3 and plus 4. Well, they're not the only factors, but plus 3 and plus 4 will work in this situation. If you multiply all these out, you'll get x squared plus 7x plus 12. So then we have a product of factors giving 0. That means that we can put either of these equal to 0, which means that x equals minus 3. And from the other factor, we get x equals minus 4. So now we've found all the roots of our cubic equation. So there are at most 3 roots, as I explained earlier. That's because the highest power of x is 3. But sometimes there's only 1 root, or 2 roots. But at most 3 different roots. Let's check these roots. We know that f of 1 is going to give us 0. So we don't have to do that. What about f of minus 3? Well, let's plug minus 3 into the cubic polynomial. We get minus 3 cubed plus 6 times minus 3 squared plus 5 times minus 3 minus 12. This should all work out to 0. So you can plug all this into your calculator. Now, with some calculators you have to be careful when you raising a negative number to a power. You actually have to put in brackets because the calculator doesn't take the minus sign into consideration. Okay, we can also do this without a calculator. Minus 3 cubed is minus 3 by minus 3 by minus 3. That's minus 27. Minus 3 squared is plus 9. 6 nines are 54. Plus 5 by minus 3 is minus 15. And then we have minus 12. Minus 15 minus 12 is minus 27. Minus 27 minus 27 is minus 54. And then we have plus 54. That gives us 0. So minus 3 is indeed a solution. Let's look at minus 4. We have minus 4 cubed plus 6 times minus 4 squared plus 5 times minus 4 minus 12. Minus 4 cubed is minus 64. Minus 4 squared is plus 16. 16 times 6 is plus 96. We get minus 20 here, and then minus 12. Minus 64 minus 20 is minus 84. Minus 84 minus 12 is minus 96. So we end up at 96 minus 96, which is 0. To see a graph of the cubic polynomial, you can just type it in here. And you can see that the graph has 2 turning points. That's the general situation for a cubic polynomial. So we're actually drawing the graph of f of x equals this, or if you like, y equals all of this. And when y is 0, x is minus 4, or minus 3, or plus 1. So the graph crosses the x-axis at the 3 roots. So we can call our function y if we like. It's just the same as f of x. And we're interested in points on the graph where y is 0. So if we put this equal to 0, but y equal to 0, well, we're just solving this cubic equation. And we got our 3x values. So the coordinates of this point here are minus 4, 0. The coordinates of this point are minus 3, 0. And the coordinates of this point are 1, 0.